In the vast expanse of our solar system, Jupiter stands as a giant, its gravitational pull influencing a myriad of celestial objects. Among these are its many moons, each with its own story to tell. Today we journey to one such moon, a small icy world known as Aitne. This enigmatic moon, designated as Jupiter 31, is a retrograde irregular satellite. This means it orbits Jupiter in the opposite direction to the planet's rotation. Aitne is a fascinating object that provides clues about the formation and evolution of our solar system. Aitne's story began in the early 21st century. In December 2001, a team of astronomers led by Scott S. Shepard made a remarkable discovery. Using the powerful Canada-France-Hawaii telescope atop Mauna Kea in Hawaii, they observed a faint object moving against the backdrop of distant stars. This object, initially designated as S2001J11, turned out to be a previously unknown moon of Jupiter. This discovery added to the growing list of Jovian satellites and opened a new chapter in our understanding of the Jovian system. Aitne's orbit is a testament to the complex gravitational dynamics at play in the outer solar system. This small moon, named after a figure in Greek mythology, is one of Jupiter's many irregular satellites. These moons are characterized by their unusual orbits, which are often highly inclined and eccentric compared to the regular moons. Aitne in particular belongs to the Carm group, a family of retrograde moons that share similar orbital characteristics. It orbits Jupiter at an average distance of 22,285,000 kilometers. This vast distance places Aitne in the outer reaches of Jupiter's gravitational influence, where the pull from the Sun and other planets can also affect its path. The interplay of these forces creates a delicate balance that keeps Aitne in its unique orbit. This places it far beyond the orbit of Jupiter's four largest moons, Io, Europa, Ganymede, and Callisto. These Galilean moons are much closer to Jupiter and have more regular circular orbits. In contrast, Aitne's distant and irregular path highlights the diversity of celestial mechanics at work in our solar system. Aitne takes approximately 712 Earth days to complete one orbit around Jupiter. This lengthy orbital period is a result of its great distance from the planet. For comparison, Earth's moon takes about 27 days to orbit our planet, illustrating just how far Aitne is from Jupiter. Its orbit is also highly eccentric, meaning it is not perfectly circular but rather slightly elongated. This eccentricity causes Aitne to vary its distance from Jupiter significantly over the course of its orbit, sometimes coming closer and at other times moving farther away. This variation can affect the moon's speed and the gravitational interactions it experiences. What makes Aitne's orbit particularly intriguing is its retrograde nature. Retrograde orbits are those in which a moon or planet moves in the opposite direction to the rotation of its primary body. In Aitne's case, it orbits Jupiter in the opposite direction to the planet's rotation. Unlike most of the planets and moons in our solar system, which orbit in the same direction as their host star's rotation, Aitne moves in the opposite direction. This retrograde motion is thought to be the result of a capture event, where Aitne was likely an object that formed elsewhere in the solar system and was later captured by Jupiter's gravity. This capture scenario adds another layer of complexity to the story of Aitne and its dance around Jupiter. Although small compared to Jupiter's larger moons, Aitne is still a significant celestial object in its own right. Named after one of the nymphs in Greek mythology, Aitne is part of a group of moons known as the Carmi group, which share similar orbits and characteristics. These moons are thought to be remnants of a larger body that was broken apart by collisions in the distant past. It has an estimated diameter of about 3 kilometers, making it one of the smaller moons in the Jovian system. Despite its size, Aitne's orbit around Jupiter is quite remarkable. It takes about 732 Earth days to complete one orbit, which is much longer than the orbits of Jupiter's larger moons like Io, Europa, Ganymede, and Callisto. Its surface is likely composed of a mixture of ice and rock, typical of many objects in the outer solar system. This composition suggests that Aitne, like other moons in the Carmi group, may have originated from a captured asteroid or a fragment of a larger body that once orbited the Sun before being captured by Jupiter's gravity. Due to its small size and distance from Earth, Aitne appears incredibly faint. Observing such a distant and dim object requires advanced technology and precise instruments. Astronomers rely on powerful telescopes equipped with sensitive detectors to study Aitne and other similar moons. Its apparent magnitude, a measure of its brightness as seen from Earth, is 22.7. This makes Aitne one of the faintest objects in the Jovian system, challenging astronomers to gather detailed information about its properties and behavior. This means that Aitne is far too faint to be seen with the naked eye and requires powerful telescopes for observation. The study of such small and distant moons helps scientists understand the complex gravitational interactions in the outer solar system and the history of celestial bodies that orbit the giant planets. Section 5. The Carme Group, a family of retrograde moons. Aitne is not alone in its retrograde journey around Jupiter. It belongs to a group of Jovian moons known as the Carme Group, named after the largest member of the group, Carme. This group consists of over 24 moons that share similar orbital characteristics, including their retrograde motion, high inclinations, and eccentric orbits. These similarities suggest that the moons of the Carme group may have a shared origin story, perhaps born from a larger parent body that was captured by Jupiter's gravity billions of years ago. Section 6. Mythological Origins. Aitne, the Divine Mountain Mother. The naming of celestial objects has always been intertwined with mythology and folklore. Aitne's name is no exception. In Greek mythology, Aitne was a divine nymph associated with Mount Etna, the active volcano in Sicily, Italy. She was known as the personification of the mountain itself, and was said to be the mother of the Palici, twin gods associated with geysers and hot springs. The choice of Aitne's name reflects the tradition of naming Jovian moons after figures from Greek and Roman mythology, particularly those associated with Zeus, the Roman equivalent of Jupiter. Section 7. Scott S. Shepherd, a prolific discoverer of celestial wonders. The discovery of Aitne is a testament to the dedication and ingenuity of astronomers like Scott S. Shepherd. His relentless pursuit of knowledge and his passion for the cosmos have driven him to explore the farthest reaches of our solar system. Shepherd's work is not just about finding new celestial bodies, it's about understanding the intricate dynamics and histories of these distant worlds. A prominent figure in the field of planetary science, Shepherd has dedicated his career to searching for and studying small bodies in the outer solar system. His meticulous observations and innovative techniques have led to groundbreaking discoveries that have reshaped our understanding of the solar system's architecture. Shepherd's contributions are not limited to moons. He has also identified numerous trans-Neptunian objects, which are crucial for understanding the early solar system. His work has led to the discovery of numerous moons orbiting Jupiter, Saturn, Uranus, and Neptune, significantly expanding our knowledge of these distant planetary systems. Each new moon discovered provides valuable data that helps scientists piece together the history and evolution of these giant planets. Shepherd's discoveries have also shed light on the processes that govern moon formation and the complex gravitational interactions within planetary systems. Shepherd's contributions to astronomy go beyond the discovery of Aitne. He has been instrumental in advancing our understanding of the Kuiper Belt and the scattered disk, regions of space that are home to some of the most primitive and distant objects in the solar system. His research has provided insights into the distribution and composition of these objects, offering clues about the conditions in the early solar system. He is also credited with discovering some of the most distant objects ever observed in our solar system, pushing the boundaries of our understanding of the solar system's vastness. These discoveries have important implications for our knowledge of the solar system's formation and evolution. Shepherd's work continues to inspire and challenge astronomers around the world, driving the quest for knowledge and the exploration of the unknown. Section 8. The importance of studying irregular moons. The study of irregular moons like Aitne is crucial for unraveling the mysteries of our solar system's formation and evolution. Their unusual orbits and compositions provide insights into the complex gravitational interactions and collisions that shaped the solar system billions of years ago. By studying these celestial remnants, we can piece together the history of our cosmic neighborhood and gain a deeper understanding of the processes that led to the formation of planets and their moons. Section 9. Conclusion. Unveiling the secrets of Aitne and beyond. Aitne, the small icy moon with a retrograde orbit, stands as a testament to the vastness and complexity of our solar system. Its discovery and ongoing study continue to challenge our understanding of planetary systems and inspire us to explore the cosmos further. As we continue to peer deeper into the universe, we can expect to uncover even more secrets hidden among the stars, further enriching our understanding of our place in the cosmos.